Hey everyone, so today we're going to talk about something wild. How your phone is basically a time machine in your pocket and how that's the only reason your GPS actually works.
I mean, really think about it for a second. You pull out your phone, you open up a map, and bam, there you are, that little blue dot. It feels like magic, right? But the truth? Oh, the truth is so much cooler than magic. It's all about physics.
Yeah, you heard that right. The only reason your GPS is accurate, and not, telling you you're in the next town over, is because it has to account for a tiny glitch in time itself. So let's unpack what that even means.
All right, so first up, the 38 microsecond glitch. And believe me, this tiny error has some massive consequences.
Okay, so here's the basic idea of how GPS works. You've got these satellites way up in orbit, right? They're constantly beaming down signals, and each signal has a super precise timestamp from an atomic clock. Your phone grabs these signals, compares the timestamps, and boom, it triangulates your position. But here's the catch. For any of this to work, the timing has to be absolutely perfect.
And it's not perfect. See, every single day, the clocks on those satellites get ahead of the clocks down here on Earth by just 38 microseconds. We're talking 38 times millionths of a second. I mean, that sounds like nothing, right? Who cares?
Well, you should care. Because if we didn't correct for that tiny, tiny drift, your GPS would be off by 10 kilometers every single day. And just a couple of days, your phone would think you're in a totally different city. It would be completely useless. So, what in the world is causing this glitch in time?
Well, to understand that, we have to talk about a fundamental rule of the universe, the cosmic speed limit.
And here's the rule, coming to us straight from Albert Einstein. It's called the constancy of light. And it's simple, but it breaks your brain a little bit. It just says the speed of light is always the same. For everyone, no matter how fast you're moving. Standing still, light moves at light speed. On a rocket ship going almost the speed of light still moves at light speed. It's the universe's ultimate speed limit.
And this is where things get really weird. Because this is just not how our world works, right? Like, if you're in a car going 50 miles an hour and you throw a baseball forward at 10 miles an hour, that ball's moving at 60. Speeds add up. But light? Nope. Light's a rebel. You're on a rocket going 99% the speed of light, and you turn on a flashlight, the light from that flashlight just leaves at the speed of light. Not the speed of light plus the rocket speed. Just light speed. And that one simple, bizarre fact changes everything.
So, how do we get our heads around these consequences? Well, let's try a classic thought experiment, the light clock. Okay, stick with me here. Imagine a clock, but instead of hands, it's just two mirrors with a single photon of light bouncing between them. Tick, it hits the top mirror. Tock, it hits the bottom one. Easy enough, right? If you're standing still next to this clock, that photon is just going straight up and down. But what if we put that clock on a super fast spaceship? For someone watching from the outside, that photon now has to travel a longer, diagonal path. It's still going from one mirror to the other, but because the mirrors are moving, it has to travel in a zigzag.
And here is the mind-blowing part. The zigzag path is longer than the straight up and down path. But we already know the speed of light can't change. It's the cosmic speed limit. So, if the distance is longer, but the speed is the same, something else has to give. And that something is time. Time itself has to slow down for the moving clock to make the math work. This isn't a trick, it's a real effect called time dilation.
Okay, so what does a weird thought experiment about a light clock have to do with your phone? Well, this isn't just a thought experiment, it's a very real problem that engineers have to solve every single day. Remember that 38 microsecond drift? The one that throws GPS off by 10 kilometers a day? That's not because the clocks are bad. That is time dilation. It's happening in real life right now. Those satellites are whipping around the Earth so fast that their clocks are literally ticking just a tiny bit slower than ours down here, exactly like Einstein predicted. So what do the engineers do? They embrace the physics. They use Einstein's own equations to calculate that exact time difference. They know the clocks on the satellites are going to run at a different rate because of their speed, so they build a constant correction into the system. They literally program relativity into the GPS network. Without this Einstein correction, your phone's map would be worthless in just a few hours. And honestly, this is the part that just gets me every time. Every single time you use your phone for directions, you are personally participating in a global experiment that proves Einstein's theory of relativity is right. It's not some dusty old idea, it's living, breathing physics happening in your pocket, millions of times a second.
Okay, so why should we care about all this? I mean, beyond just making sure we don't get lost. It's because it shows us that these crazy abstract rules of the universe, they're not just for physicists in a lab.
Relativity is everywhere, once you know where to look. It explains weird things, like why certain particles from space, muons, can even reach the ground. They should decay long before they get here, but they're moving so fast that time slows down for them, and they live longer from our perspective. And of course, there's the famous twin paradox. You know, send one twin into space at near light speed, and they'll come back younger than the twin who stayed home. They literally time traveled into the future.
So the big takeaway here is pretty simple. All this abstract physics, this stuff that sounds like science fiction, it's not just in textbooks. It is a real working part of the tech we all rely on every single day.
So I'll just leave you with this to chew on. If time itself isn't a constant, if it actually changes depending on how fast you're moving through space, what does that mean for our idea of a single universal reality? Kind of makes you think, doesn't it?